AP Statistics. In this video, we're going to talk about example 7, computer output. I'm just going to go over with you how to read computer output and what we're going to use it for. We are in Unit 2. So when we look at linear regression, something you need to realize is that if you were doing a linear regression out in the real world, like let's say you're a statistician and you work for some company and you want to create a prediction equation based on data you've collected over several years or something like that, you're not going to be carrying your TI-84 calculator around at work with you, okay? You're going to have very sophisticated statistics software, and it is going to find what you need for you once you put your data into it. So that's why we're going over computer output, because that's generally how in the real world we calculate a linear regression. So if you'll notice here on example 7, I've got a regression analysis from a software called JumpIn. I've got one down here from Minitab, and then I've got one here from a company called DataDesk. So it's all the same data, so you can see how it compares. So our model that we have here, we've got Bismarck, North Dakota temperatures. We're using those to predict temperatures in Buffalo, New York. So in JumpIn, I want you to recognize a few things. There's a lot of information here. Okay, so let me first set your mind at ease. We are only looking for 4 things in our computer output at this point in time. So I am going to look for R squared. I'm going to look for the standard deviation of the residuals. I am going to look for slope, and I am going to look for y-intercept. Now, once you figure this out for one type of software, it's usually pretty easy to do it in another type of software because there's a lot of similarities. So the first thing we want to look at is R squared. Now, usually in computer output, they're going to use like R squared like that. Okay, so that's R squared. Sometimes they'll do something like down here in the Minitab, they'll just use an abbreviation, R-SQ. So you're looking for something like that. Please keep in mind they'll never give you R, the correlation. They will always give you R squared. So if you want to find R, you would have to take the square root of your R squared in order to get R. So keep that in mind. Okay, the next thing we're going to tackle is the standard deviation of the residuals, because remember, the standard deviation of the residuals tells me how much typical variation I can see in my values as it pertains to the distance away from the LSRL. So for this one, it's a really weird name. It's the root mean square error. So when we're talking about standard deviation, you'll find this out later as we go through other units. Standard deviation will be referred to as standard error. And this idea of its root mean square, that's because that involves taking the square root and averaging and whatnot in the formula for standard deviation, which I don't make you calculate by hand. So that's why it's called something funny. So if you can't find S, which is typically what it is, see like down here, see how these values are the same? Okay, normally it's S, the standard deviation of the residuals, but every once in a while you'll see it called the root mean square error. All right, the other things we're interested in are slope and y-intercept. Now, to find these, you're looking for 2 words. You're looking for your explanatory variable, and you're looking for the word either intercept or constant for your y-intercept. So let's look for those words here. So I'm looking down here. Okay, there's nothing here. There's nothing here. Tra-la-la. Oh, look. Intercept. You know what that means? This is the y-intercept. The number right next to that is the y-intercept. Bismarck, that is my explanatory variable. So this right here is the slope. Okay, just like in our equation, our prediction equation, a plus bx. See how the slope is multiplied by the explanatory variable? See, those are right next to each other. That should make sense to you. So what would we use our computer output for? Well, once you've got the slope and y-intercept, you can easily write your regression equation. So you can do this, buffalo temperature, predicted, and then you can write your equation. And by the way, if the slope is negative, it will put a negative out in front of it, just FYI. And then your Bismarck temperatures. And see, once you've got your equation and once you've got your R squared and your standard deviation, you can answer all kinds of questions about your linear regression. So keep that in mind. If you've got all that, you've got a lot. Okay, so if we're looking at Minitab, notice this one's real nice. They give you the equation straight up. You don't even have to think about it. You don't have to look for where any of your values are. But notice this time they use the word constant for the y-intercept. So keep that in mind. They're either going to use intercept or constant, excuse me. Okay, something else to note here. Some of the computer outputs will give you R squared adjusted. That just means they've adjusted it for whatever reason. We don't use that at all. So R squared adjusted, bad. R square, good. Okay, then this is a regression from Datadesk, and typically what you'll see on a linear regression question where they want you to build the equation, you'll be given some information like this. See, I've got my R squared here, I've got my standard deviation of the residuals, I've got my y-intercept, and I've got my slope right here. But they've also provided you with a scatter plot and your residual plot. So you can answer more questions about the appropriateness of the linear model, etc., etc. Okay, there's also a good example in your book on page 193, and that's a typical example of what you might see on the AP test, because on the AP test they don't give you all this jazz, usually. All right, sometimes they will, but not always.